Today we're going to take a quick look at orbits. An orbit can be described as the curved path followed by one celestial object or spacecraft as it moves around another celestial object due to gravitational attraction. For example, this could be the Earth moving around the Sun, or the Moon moving around the Earth. The key question we are going to try to answer in this video is why objects behave this way and move in an orbit rather than simply flying off in a straight line or being pulled directly into the object they are circling. According to Newton's first law of motion, an object moving at a certain velocity will continue to move at that velocity unless it is acted upon by a resultant force. So, if the Moon is moving in a particular direction at a speed of 1,023 meters per second, which we refer to as its instantaneous velocity, it should theoretically continue to move in that direction at the same speed indefinitely. However, because the Earth is enormously massive and relatively close to the Moon, it exerts a significant gravitational force which acts as a continuous attractive force, pulling the Moon toward the Earth. Now, the Moon, being relatively large and traveling at a high speed, has a substantial amount of momentum in its current direction of travel. As a result, the gravitational pull from the Earth is not strong enough to drag it straight down but is strong enough to continuously alter the Moon's direction, just slightly. Because this gravitational force is constantly acting on the Moon, it is always slightly changing its direction of travel. Over time, this results in the Moon moving in a stable and continuous orbit around the Earth. This is why the Moon does not crash into the Earth or escape off into space. One of the more confusing aspects of this situation is understanding how speed, velocity, and acceleration are related in the context of an orbit. Although the speed of the Moon remains constant, its direction is always changing as it orbits the Earth. Since velocity is defined as a quantity that includes both speed and direction, this means that the velocity of a Moon is constantly changing. If velocity is changing, then by definition, the object must be accelerating. According to the equation for acceleration, which tells us that acceleration is equal to the change in velocity over time, it becomes clear that any change in direction, even with constant speed, is considered acceleration. Therefore, every time the Moon shifts its direction as it continues in its orbital path, it is in fact accelerating. This might seem strange because we often associate acceleration with speeding up or slowing down, but in physics, acceleration includes any change in velocity, whether that change involves speed or direction or both. So, the key point to understand is that because the Moon's direction is changing continuously due to Earth's gravitational pull, its velocity is changing as well, and this change means the Moon is constantly accelerating even though it maintains a constant speed. When we put all of this together, we see that two crucial factors determine orbital motion. These are the instantaneous velocity of the orbiting object and the gravitational attraction of the larger object around which it is orbiting. It is the balance between these two factors that allows an object to follow a stable orbit instead of either flying away or being pulled inward. The final concept we need to consider is the relationship between the size of an object's orbit and the speed it must travel in order to stay in that orbit. Let's imagine that the Moon's orbit was pulled inward, bringing it closer to the Earth. As the distance between the Earth and the Moon decreases, the gravitational force between them becomes significantly stronger. If the Moon maintained its original speed in this smaller orbit, the increased gravitational force would likely cause it to spiral inward toward the Earth. To avoid this and maintain a stable orbit at the new closer distance, the Moon would need to travel at a faster speed, meaning its instantaneous velocity would have to increase. This higher speed would provide the additional momentum needed to balance the stronger gravitational pull and keep the Moon from crashing into the Earth. So, the takeaway message is that the smaller the orbit of an object is, the faster it needs to travel to remain in stable orbit. If the object is not moving fast enough, it will be pulled into the body it is orbiting. On the other hand, if it moves too fast, it might escape the orbit altogether. Maintaining the right speed for the size of the orbit is what allows the object to continue moving in a smooth and consistent path around its central body. That is everything we wanted to explain in this video. If you found this explanation helpful and enjoyable, please consider giving us a like and subscribing to our channel, and we look forward to seeing you again in another educational video very soon.